In the previous video, we talked about how to build what is a difference amplifier, how to build one. In this one, let's talk about how to do a difference amplifier with two op-amps. This circuitry will based on a non-inverting op-amp circuitry with a reference input. We have analyzed this in video number 4. If you want to check back, you can look that video first. So the basic circuitry for a non-inverting amplifier input is like this. We have a Vin plus, let's call that V input plus the positive input, and we have a reference here Vr and V out, R1 the feedback resistor, and R2 the input resistor. Okay. The transfer function for this one, we have a quick way to write that transfer functions. We just refer everything, all the input output with respect to VR. So now Vin plus turn into Vin plus minus VR. Here's VR minus VR is 0, and V out minus VR, the output. Okay, and because it is a 0 voltage, then we can quickly write down the transfer function. It looks like V out minus VR equals 1 plus R1 over R2 times the input, which is V in plus minus VR. Okay, and let's write clean up this equation. We have 1 plus R1 R2 V in plus V in plus and minus 1 plus R1 R2 VR. Okay, and we can move the VR to this side, so we got V out equals 1 plus R1 over R2 V in plus and the minus 1 plus R1 over R2 VR plus VR. Okay, and we can simplify this like 1 plus R1 over R2 V in plus minus R1 R2 VR. Okay, this transfer function, we have talked about this before. It's very straightforward results from the non-inverting op-amp circuitry with a reference input. We want to build a difference amplifiers. So what if VR equals 1 plus R2 R1 V in minus? Okay, because VR is a reference voltage, could be any voltage within the power rail. And what happens if VR happen to be 1 plus R2 divided by R1 times V in minus? Okay, what happened now? We plug this into the equation, then we have a V out equals 1 plus R1 R2 V in plus minus R1 R2 times 1 plus R2 R1 V in minus. Okay, so this is V out equals 1 plus R1 R2 V in plus, and we multiply this into the brackets, and you will got minus 1 plus R1 R1, R2, V in minus. So V out equals 1 plus R1, R2 times V in plus minus V in minus. Okay, so this is a difference amplifier with a gain of 1 plus R2, R1 over R2. Okay, so this basically is the difference amplifiers we want, and our task now is try to have a circuitry, make sure have this output transfer function. So we can build a circuitry like make the VR VR's output now equals 1 plus R2 over R1 V in minus. Okay, if you look this carefully, this just another non-inverting op-amp circuitry, right? So that means we can build another circuit here. Let's clean up these plots first. We need VR has a value of this. We just build another op-amp circuitry, a non-inverting op-amp circuitry like so. And we have a V in minus, and this is the feedback resistor should be R2, and the input resistors are 1, and the output is VR. So we connect the VR to here, to the VR input. Okay. Now, this is a 2 ohm difference amplifier. Okay. This is basically, this is a cascade with 2 non-inverting op-amp circuitry. Although the first, this input have a feedback resistor R2 and input resistor R1, and the second op-amp we have a feedback resistor R1 and the input resistor R2. And the one side of the input is V in plus goes to the second op-amp, and the V in minus goes to the first op-amp here. So you can basically use 2 identical op-amps for this circuitry. This has a lot of benefits compared to the typical 4 resistor 1 op-amp difference amplifiers we talked about in video number 9, I believe. And most important properties, because now we have a high impedance input for both V in plus and V in minus. We could talk about some examples later why this is important if you have a high impedance input, because this input is directly into the op-amp. Ideally, with the ideal op-amp, you have infinite input impedance. This is very important in the circuitry, in some circuitry. And of course, there's some pros, cons here. And the one drawback of this circuitry is because it's a non-inverting configuration, so that you always have a gain bigger than 1, right? Because 1 plus R1, R2 will be bigger than 1 all the time. It doesn't matter how you configure R1, R2. And this another drawback with this 2 op-amp difference amplifier configuration is it's hard to set a reference output for this for the out, because once you take the difference between 2 inputs, you remove the common mode voltage. You most likely want to reset the common mode voltage to a different values. This can be done, but it's not very straightforward. Okay. Hopefully, this can help you to understand the difference amplifiers, especially this special case with two op amps. I find this is very interesting. Thank you.